So I just wanted to do a video about the refraction of light, as this gets brought up a lot when they say that we see too far and it's refracting around the curve. So it says we see using our eyes as detectors and brains to process the information. The eye-brain system assumes that light travels in straight lines. You saw how this causes the brain to see things that aren't really there when we look at virtual image in a mirror. The unit is concerned with virtual images formed when light passes from one substance to another. Okay, so whenever a wave passes from one substance into another, there is a change of speed. The consequences of this speed change can be seen by studying water waves in a ripple tank. Figure 1 shows what happens when water waves are slowed down as they pass into a shallow water region. So here's the deep water, and as it goes into the shallow water, the waves slow down. You can see the change. So these ones faster waves in the deeper water, and as it goes to the shallow water, the waves actually slow down. So notice how the parts of the wave in the shallow water lag behind those travelling in the deeper water. This change in wave speed is called refraction. So refraction is the change in wave speed. When the waves emerge from the shallow water, they speed up again. Okay? So then over here somewhere, this one. So the change in direction as light leaves water or glass can be used to explain why the bottom of the swimming pool appears to be nearer than it really is. As light leaves the water, it changes direction, moving away from a line drawn at right angles to the water surface. Figure 5 shows how this leads to the formation of a virtual image. Figure 5. Virtual image. This is where the light appears to have come from. So that's where the light appears to have come from, and this is where the light really came from. That's why it appears shallower to the observer, nearer than it really is. So they see the bottom of the pool here because the light's refracted. Now they say the refraction of light is when it moves from a less dense to a more dense. This is just in water, and it's not moving from less dense to more dense. If anything, it's moving from more dense to less dense as in the air, or from the same density to the same density, as water is pretty much the same density. It does change a little bit, but I think it might actually be towards the surface and then less as it goes down to where it pretty much reaches a constant. But yeah, this is where you picture the bottom of the pool, but this is where it really is. So if we imagine this through air, the atmosphere, this would be where the boat really is, and this would be where it appears to be when it's refracted. But it's not going around a curve, and as you can see, it's not from a more dense to a less dense. From a less dense to a more dense. If anything, it's from a more dense to a less dense, and not from a less dense to a more dense. So let's just draw a diagram. So if we draw the Earth as a ball, and then we've got, say, a boat here. It's going to be a crap drawing because we're just doing, an example. So this is a boat, and this is the observer. The light comes from the boat, so we've got less dense atmosphere up here and more dense atmosphere here. And the light comes from the boat, and it apparently comes to us. And as it bends round, because if it was to go in a straight line from the boat, it would just go, that's not really a straight line, but it would go like this, like a straight line. And they're trying to say it bends towards the dense medium. Now, what makes more sense, this, because this is bending towards a denser medium, but there's nothing about a denser medium in this. And this is bringing it closer. So if anything, it appears here, but it's not going around any curve or going from less dense to more dense. Whereas if you have a flat earth, and then you have the boat over here, so this is the boat, and say this is the observer, and then say it appears to be here, you could have the light appearing to be here, because as you look through, this is all the same density, but obviously you're looking through more and more atmosphere. And because you're looking through more, it's kind of hard to explain, but so the light waves come off here and they get refracted to here by a change of wave speed, because it's the changing of the speed of the wave which causes the refraction. The change in wave speed is called refraction. So the wave speed must change to cause refraction in order for it to be here. So like in this diagram, the wave speed must change as it gets to shallower water, like that. And as it gets to shallower water, it changes. The only thing that I can really think of is pressure. So maybe there's a pressure change in the atmosphere, and then that causes refraction, and then we see it closer.